A mole is an animal that burrows in the ground, or a spot on your chin that you've got to shave around. But there's another kind of mole of interest to me, and that's the kind of mole they use in chemistry. So what are the three kinds of mole? What are the three kinds of mole?
Mole is an animal.
A mole is an animal. Should we write that one down? That burrows in the ground. I usually draw this little diagram for when something is going to be due on mole day. I put this little thing here. Doesn't that kind of look like a cute little mole, like reaching over a, I don't know, what would a mole reach over? A hole. He's coming out of a hole in the ground from your nightmares. Would you like to contribute another kind of mole? Anyone? Nope. No comment. Refuse to respond.
Is it? Is a spot on your chin that you got to shave around?
And because you forget to shave around it, the hair grows out. But there's another kind of mole of interest to me, and that's the kind of mole they use in chemistry. Say it. Come on.
10 to the 23rd.
No, say the song.
6 times.
No, come on. A mole is a unit, or have you heard, containing 6 times 10 to the 23rd. That's a 6 with 23 zeros at the end. Much too big a number to comprehend. Okay, so we got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's actually 23 zeros. One of them's a 2. 3, 6, 9, 12, 15, 18, 21, 22, 23. That's much too big a number to comprehend. Doesn't it seem like that's much too big a number to comprehend? But that's how much money Lucas has in V-Bucks. If only, though. That's actually that's the Gen Z dream, is 6.202 times 10 to the 23rd V-Bucks. Think of what you could buy. What are the new skins on Fortnite?
Oh, Courage just came out.
Courage the Cowardly Dog. Courage the Cowardly Dog. So how do we actually use this unit? These things don't, that's just cute. These are just cute. This one's the one we're actually going to do. How do we use this unit? This will be a very brief discussion. I have a video which I liked comparing this, that I have made. So that's actually really the height of egoism for me to say that I like it also. But comparing this to a dozen. And if you've ever been on TikTok, very famous on TikTok. And so that TikTok talks about how a dozen can be a dozen of anything. Right? It's a count. This is a way of counting. It's a unit that counts things. It's a unit of amount. It's actually the SI base unit for amount. It can be 6 times 10 to the 23rd of anything. So the example I gave was in that very famous TikTok was that could you have a dozen of anything? Of course you could. Could you have a dozen ice cream cones? Yes, that would be 12 ice cream cones. Could you have a dozen donuts? That's 12 donuts, right? And then in the video I say that you could have a dozen teeth, and then I say there are some people in this town who don't have but a dozen teeth, and everyone laughs at that. You know someone? You know their name. Don't say it though, because this is going out. I know someone with exactly a dozen teeth. You could have a dozen of anything, and in the same way, you could have conceptually, you could have a mole of anything. The way that we use the mole is that, like that song says, shake a little sugar in the middle of your palm, because that might be about a mole of sugar atoms. But remember the other parts of the song where it was like a mole of marshmallows blots out the whole sky, and a mole of paper goes to the moon and back 20 billion times or something like that. You remember these things? It's a huge number, but when it's atoms, it goes in the middle of your palm, because atoms are so very, very small, you understand. So how we use this is if we have, let's say, we'll just do example math now, 2.3 atoms of silver. If we have 2.3 moles of silver, and we want to go from moles of silver to atoms of silver. By the way, depending on what kind of particle we're talking about, or what kind of substance we're talking about, we only do this with pure substances, not mixtures, but depending on what kind of substance we're talking about, we will either use we'll use a different term for the type of particle. So why is it atoms of silver? What kind of substance is silver?
It's a metal.
Okay, it is a metal, but it's a what? Where do we find silver?
Transition metal.
Yes, but where do we find these things? On the periodic table of the elements. So since silver is an element, the representative particle of silver is an atom. So the representative particle, that means the particle that represents the lowest possible configuration of that thing for an element, is an atom. The representative particle of an element, I abbreviate that as LM, is an atom. Do you know what it might be? I think you will know this one. If it is a covalently bonded substance, you know how to identify whether it is covalently bonded or not, based just on its name or formula. If it's covalently bonded, what would its representative particle be?
Ions.
No.
Element.
Nope. Element is a
Electrons.
No. You know it. It's a group of atoms covalently bonded together. It's called a, there you go, molecule. What if it's ionically bonded?
Valence electrons.
Okay, so it involves valence electrons, but that's not what the representative particle is named. It's actually a formula unit. Formula unit. We should just abbreviate FU, and that's not a joke. We actually do abbreviate it that way. Ionically bonded, we call it a formula unit. And what if it itself is an ion? Well, then it's an ion. I think that covers all of them. So if we had 2.3 moles of silver, want to find out how many atoms that is. It's a very simple kind. What kind of math might we do with this? You have a little hint in how I set it up. Is this going to be an equation?
Yes.
Not an equation. No, not an equation.
Calculator problem.
A calculator problem it is. A conversion, a unit conversion. So we start out with 2.3 moles. Another, by the way, moles, the abbreviation is MOL. The actual word is MOLE, so it's like the worst abbreviation in the history of abbreviations. We're only cutting off one letter. There actually are, let me give you an even worse one. Do you know what WWW stands for?
World Wide Web.
It stands for World Wide Web. How many syllables is World Wide Web?
3.
World Wide Web. How many syllables is WWW? WWW is 9 syllables, so that's a worse abbreviation. But anyway, mole is not a very good one either. Mole, the abbreviation is just MOL. To convert that, we go from moles of silver. We want to go to atoms of silver. In 1 mole, it doesn't even matter what it is. In 1 mole, there are always what?
Did you see we're doing a video?
Answer it.
She has a mole.
Answer it. Answer the question.
We don't know.
Yes, you do. In 1 mole of anything, there are...
6.02 times 10 to the 23rd.
You're right. Now to do that math, you're right. It's calculator math. Okay, so to do this, good thing since I paused it, we all use this to do our calculator math.
Yeah.
On our calculator, we would type 2.3 times 6.02 times 10 raised to the 23rd power, or I prefer 2.3 in parentheses the quantity 6.02 little baby e, not the small minuscule e, but the majuscule e, but it's small. 23. So on your calculator, what it looks like is, just toss me one of them calculators, mucus. Okay, on the calculator, is this showing up? Is calculator showing up?
Yeah. Right there.
This on this one, it is shift log. It's usually shift log. You see on this one, it comes up as a little baby 10. On some, it comes up as a little baby capital E, but that takes the place of times 10 to this. So on my calculator, I would write 2.3. I would do that in parentheses though. 2.3, and then in parentheses 6.02, shift log is times 10 to the 23rd. Those have to be in parentheses so it turn out right. You can see it comes up with 1.385 times 10 to the 24th. 1.385 times 10 to the 24th. 1.385 times 10 to the 24th atoms of silver. Moles of silver has reduced out. We're left with atoms of silver in our numerator, so that's the unit.
A lot of atoms.
There's a lot of atoms. But
Not a lot.
atoms are so very, very small, you understand. You could fit a mole of silver atoms in the palm of your hand. Let's find out how. Well, what if we had 2.3 moles of silver, and we, instead of wanting to go from moles of silver to atoms of silver, brethren, we wanted to go to grams. So we're going to go from moles of silver to grams of silver. How would we find this? Can you think of anywhere where there's a known value that will convert from moles to grams? We might call it grams per mole. Where can we find the number of grams per mole of something?
In the book.
Okay.
www.
No, on www would work, on the book would work, but those are neither of them the answer I'm looking for. The periodic table of the elements. Coincidentally, and you're about to find out this is not a coincidence, coincidentally, the average atomic weight of an atom, or the average of all the isotopes of that atom, is numerically equivalent to how many grams 1 mole of that has a mass of. I was going to say weighs, but has a mass of. The reason that's not a coincidence is because that is actually how Avogadro's number, BTW, we call this Avogadro's number. We do. We have 2 names for it. Kind of like some people call you Lucas and some people call you Mucus. So we have 2 names for this, but we call. Well, you made me lose my train of thought. Oh, the mole is defined as how many atoms it takes to make 12 grams of carbon-12. It relates the quantities. You should probably write that down. 12 grams, 12 point infinite zeros, 12 grams of carbon-12. Why specifically carbon-12? Well, that's the isotope that was chosen, kind of arbitrarily, but it has a mass of exactly 12, and equivocating this mass with this specific isotope means, you can see 12 equals 12, that we can interchange between moles and grams freely using just that number. So in 1 mole of silver, how many grams are there of silver? And how do I know? Silver is number 47. 107.868. And we always want to use as many sig figs as we can for these. I think the periodic table I gave you guys only goes to 2 decimal places, so it can be either somewhere between 3 and 6 or 3 and 5 significant figures, but use as many as you can. Then all we have to do is multiply 2.3 times 107.86, which I would use. What kind of tool would help me do 2.3? A calc. Get out your calc.
Is your calc short for calculator?
What is the answer?
107.868
Is not the answer. Before you say the answer, how many significant figures should this have? No. 2. Should have 2. So read it in 2 significant figures.
248.
So 250 grams of silver. 250 grams of silver. Could you hold 250 grams of silver in the palm of your hand?
Yes, definitely.
I would be surprised if Sage did not have 250 grams of silver around her neck. Now say the thing about, actually, Sage, why don't you hop into the lab and write in that first counter is, we're going to assume that your necklace is pure silver. It's not. Sorry to bother you. In the front counter on the second drawer down, you'll find a scale. Just put that right on the scale and tell us what the mass is. Say what you said about this again, Garrett. You said, wow, that's a big number.
Where?
The second drawer right there. Nope, that front counter right there. Second drawer down. That's a big number. That's a lot of atoms of silver. But for the third time, atoms are so very, very small, you understand, that you can fit not only 1, but 2.3 moles of atoms in the palm of your hand, as we're about to find out. Now mass out your necklace, please. Navajo pearls, not a sponsor. What else about Navajo pearls? We're going to assume, for the case of this, they're 100% silver. I doubt that's actually true. Sorry to bother you. Okay, that's going to work. Give it to me. Can I hold it in my hand? You're probably right. So this is how much? 23 grams. So it's about a tenth of this. This is in the palm of my hand. Do you think I could hold 10 of these if I had them? Probably. I mean, it might have to be like that. Do you think I could hold 10 of these? Yeah. So that's a lot of atoms, and that's true. But you can hold not only one, in this case, math, a fifth. Is that right? Would that right? Yeah, a fifth of a mole. But I could certainly hold 5 of these, which we could assume would be about 1 mole. Maybe a little bit more than 1 mole. If I held 4 of these, that would be about a mole of silver atoms, assuming this is pure silver. Atoms are so very, very small, you understand. You can hold a mole of atoms in the palm of your hand. Thank you, Sage.
So really it's not that big of a number, guys.
It is that big a number. It's just the atoms are a little tiny. Now, could you? This will be the second to last question. Do you think you can freely convert between moles, representative particles, whatever those are, and mass?
Yes.
Okay. Now the final question. Do you have any questions?
Bye.
Bye.